Hello, welcome back friends to Technobridge Industries. In this data science series, today we are going to discuss about binomial probability distribution. In this series, I will try to teach all the aspects of data science using only ChatGPT. So let's start. So in the beginning, we are going to just mention a simple prompt in ChatGPT that explain binomial probability distribution in detail and explain it with practical examples so that it will be easy to understand. So this is a very powerful prompt in just 2 lines, and it will give you all the key insights of binomial probability distribution. So let's start. So as we all know, binomial probability distribution is a part of discrete probability distribution, and it is actually based on the trial basis, and all the trials has only 2 outcomes. Okay, so first of all, it covers the definition part. So if you want, you can go through as per the basic definition. So again, we are going to discuss all these things when we are covering the example part. Okay, so this is about the binomial distribution. So conditions for binomial distribution, there should be fixed number of trials. Okay, the trials should be fixed, only 2 outcomes per trial, maybe one success or failures. For example, if you are going to toss a coin, then maybe one head and one tail may come, right? So this is a case of binomial distribution. Okay, so probability of success is the same for each trial. So for each trial, probability of success, that should be same. This is another condition. Next condition is trials are totally independent of each other. No trials are dependent. Okay, so when we are for solving any practical problems, then it is very important to keep it into the mind when you are going to use binomial distribution concept. So these are the key conditions. Okay, so now coming to the formula. So this is the formula for what? The probability of getting exactly k successes, k number of successes in n trials. Okay, so this is the formula. So don't worry guys, if you are not getting it properly, when I am going to explain the problems, everything will be solved. My purpose of these videos are to explain you with practical problems, because these names like binomial distribution, probability distribution, so it may mean something very difficult to you, but when you are going to apply it practically, then you will see these are very simple and practical. Okay, so in this formula, what are what does it mean actually? So this part, it is nothing but the NCK as a combination. So these are the formula of combination. Okay, so NCK, this is n factorial, k factorial, n minus k factorial. So this is the formula. So hope you guys are aware of these basic formulas. So this is actually nothing but 1 into 2 into 3 into dot dot dot, everything is in k. So here it is 1 into 2 into 3, and this is so this is a very simple concept. Okay, so we have gone through in 12th or 11th. Okay, in your syllabuses. So coming to the mean and variance. So mean is the expected value, and it is a product of n into p. What is np? Again, if you go, this is the total number of trials and probability of success. Okay, and variance is the product of n, p and 1 minus p. Okay, clear? So when we solve the problem, everything will be explained. Now coming to the most important part, these are the practical problems. Okay, here we discuss about the problem of tossing a coin. So suppose we toss a fair coin 3 times. Okay, so let x is the number of heads. So as we have already mentioned 3 times, then n is equal to 3. So probability of coming head is 0.5. Okay, why? Because if you toss a single coin, so chances of getting head is 1, and total your number of opportunities of head and tail, this is 2. Okay, so this is the sample space. The total sample space is 2. This is equal to 0.5. Okay, so and here this q is nothing but 1 minus p, that is again 1 minus 0.5. This is again 0.5. Okay, so next part to when you are using the formula. So coming to the problem, what is the probability of getting 0 heads? Okay, of getting 0 head. So in that case, n is equal to 3, p is equal to 0.5, k is equal to 0 and q is equal to 0.5. So if you put this into this formula that we have already discussed, so this is the simple case scenario. Okay, so you can solve it anyway by calculator also you can solve it. So this is the thing, for 0 you are getting, for chance is 0.125. okay, for 1 it is 0.375, and for 2 it is again same, and for 3 it is 0.125. so this is a simple case of example of binomial probability distribution, and this is the distribution. You can see the table. So if you want to plot it, a very good distribution curve you will see. So you can see this kind of curve you will see if you plot it. Okay, probability versus x. So next example, it is again another very good example. A factory produces light bulbs. Okay, very important example. Light bulbs, and 5% of them are defective. Okay, so from here you are getting this probability of getting a defective is 5%, right? 5%, that is equivalent to 0.05, right? Now if you randomly pick 10 bulbs, so total sample is equal to 10, and q is the probability of getting non-defective items, that is 1 minus 0.05. This is equal to 0.95. okay, so what is the probability of exactly 2 parts are defective? Okay, 2 parts are only defective, so k, we are assuming k is 2. So again we are putting this into the formula. K p x equal to 2 is equal to 10 combination 10 to 2, and this is the formula. If you put it, this is the p to the power k, and 1 minus p to the power n minus k. Okay, so 10 to 2. So if you put this here, so this is the 10 factorial by 2 factorial into 8 factorial. If you calculate it all together, so you will get the answer. So again you have seen another practical problem. So I think now you are getting some more insights. So by that answer is, which is coming is 0.0746. if you multiply it by 100, then it will convert it into percentage, and it is coming as 7.46%. okay, so the chance of getting exactly 2 defective light bulb is 7.46%. So it is a quality control problem. So if you are from quality control department, there you have heard about the statistical quality control. So there for solving many quality issues, generally the engineers are using this concept. Okay, so coming to the next problem, this is customer purchase behavior. Okay, again it is a very practical problem. Whoever is working in a marketplace, like any shop, mega stores, so this is a very practical problem for this kind of applications. So the problem is, suppose 70% of the customer who enters to the store make a purchase. So total 70% people are purchasing. So probability is 70% means 0.7, right? So Q will be 1 minus 0.7, that is 0.3. So what is the problem statement is, if 5 customers enters into the store, what is the probability that exactly 4 will buy something? Okay, so again, why we are using binomial? The condition is very simple. If they can buy or no buy. Okay, so again there is an option between 2. Okay, yes or no, this condition. So for that we are going to use this binomial probability distribution concept, right? So let's start the calculation. Again we are putting this into the formula. Then simply you can see this C5 by 4, 0.7, that is P to the power K, and 1 minus P to the power N minus K. Okay, so this will be 5 if you calculate from the factorials, and again P is equal to 0.7 to the power 4 and 0.3 to the power 1. Okay, so if you calculate it, you can get the value. So this is 0.36. So 36% chance is there that exactly 4 people will buy something. Okay, so again this is a very interesting practical problem that clearly explain how you can use this binomial probability distribution concept to solve your practical day-to-day problems. Okay, so why this binomial distribution is useful? As when we are observing these problems, it definitely explains that it helps in predicting the outcomes in yes/no experiments. Okay, buy, no buy, head, tail. Okay, this kind of widely used in quality control, surveys, medicine trials, reliability testing, customer behavior modeling. And when you are going to apply many data science tools, then you will understand these algorithms, how they are using this binomial distribution, because this is the key concept. Okay, so when you can just go through the codes and just make the your proper data science machine learning model, you can create that, but you are using it with a Python library, right? So Python library is using its own this already generated algorithms. But whenever you are going to use any other code language, okay, So then concept will be same. The same concept will be used, maybe some different algorithm, maybe some different name will be used, but the concept will remain same. So that is why you need to understand the concept. Maybe these formulas are not that important, but concept is very important. Even in Excel also you can use this formula. Is a very simple formula is available in Excel also, so I will come to that also. So in summary, binomial probability distribution model, the number of success in n independent trials with success probability p, and this is the formula. Okay, so this is the overall summary of binomial probability distribution. So if you are watching till now, then hopefully you have learned something new. So please make comment that what next you want to learn from this channel. If you have some doubts, please come to my comment section and mention what exactly you want to understand. I will, if you want some more examples, then also you can get it. Also you can use the ChatGPT, and you can, as I have you can see this, all these things, whatever I am doing is only I am doing with the help of ChatGPT only. So after that, just you can add another prompt that please give us some more examples. Okay, give us from more examples. If you want to solve it with Excel, then you can also just write down that I want to solve this problem using Excel also. So okay, so this is how this all these concepts will be clearly explained by ChatGPT. Okay, so hope you guys have learned something new. If you have enjoyed, please do like, share and comment. Okay, thank you so much friends for being with me.